Then today I'm going to have a talk about zero energy building. But before starting about zero energy building, I want to give you a simple introduction about the sustainable architecture. In fact, zero energy building is a kind of sustainable architecture. The aim is to minimize the negative environmental impact of buildings by moderation in use of materials, energy, and development space. In general, when we are speaking about sustainability, we intend about meeting present needs without compromising the future generations' ability to meet their own needs. Then, with sustainable architecture, we are going to have sustainable with a well-built building, easy to use and beautiful as well. The main aim is to achieve the best comfort with low consumption and environmental impact. Materials, how we intend to speak about sustainable materials. The sustainable materials are materials that require a low pollution, a low polluting emission of embodied CO2. What does it mean about embodied CO2? It refers to the carbon dioxide generated during the production of building materials, during their transportation, and during construction on site, but also the release of emission of CO2 during the demolition. Then, what we are required is to look for natural materials, look for materials that that are produced or accessible on site, to don't have a very long transportation, and to have production through energy efficient production process that reduce polluting emissions. And then the materials had to be long life and high recyclability. When we speak about high energy performance building, we intend a building that requires a very low amount of energy during its lifespan. How we can achieve this kind of low amount of energy requirements? We can use the passive design strategies that require the site microclimate analysis and orientation, a high performance building envelope that means low U value that I'm going to describe better at the end, at the later slides. Use a passive solar heating, passive cooling, and natural ventilation. Use also daylighting, heating, ventilation, and cooling system efficiency, and low consumption of appliances. This is a kind of a diagram that can describe better how we can have a passive building. We can have it, as I told in the last slide, by good insulation, airtight construction, optimizing the solar orientation. We have to keep in mind that we have the directions of sun and don't have a very big windows on south directions. That means that a good design, a good architecture design. But also when we are thinking about passive buildings, we can think that passive building has always existed. In fact, in the history of architecture, domus, that was the first kind of houses in architecture history, the Roman domus, if we can see it, it's closed outside and has a country yard with shaded parts of it and water in the center. It gives more comfort living in it. And also palazzo, or the buildings, the European buildings of the 14th century, they used to have a country yard to have all the big openings on the center for the privacy and also for the shaded elements. Wikalat al-Ghuri, it's another kind of a passive design in the historical architecture. We can see that they use country yards, they use mashrabiyya, and also this kind of zones, shaded zones that give a very good ventilation for the comfort, environmental comfort in the house. Here we can see also the using of Mashrabiyya in Saudi Arabia, the vernacular houses in Riyadh. They were also a very good kind of passive design. And in the end, the wind towers used in the Gulf region in general, that gives the possibility to use take advantage of the wind present in the region. Then now I can describe better the zero energy building. When we are speaking about zero energy building, that means that buildings that have a total amount of energy, very low amount of energy generated on the site that could cover all the energy needed by the building. Why we are going to design this kind of buildings? We need to design this building to reduce the energy consumption, to reduce carbon emission, what I have described before, the embodied CO2, to reduce dependence on fossil fuels, to protect the environment for future generations, to minimize the life costs, and to achieve inner comfort. All of that is aimed to a more sustainable choice. How we can adopt this kind of buildings? We have three main features. The passive building strategies that I have described before, that are the main features of passive building in general. To have a high efficiency HVAC lighting equipment and appliances, as well as an adequate control system, are effective ways to reduce the energy consumption. It's very important to know how to design an HVAC with a very high efficiency. And of course, employing renewable energy sources on site or even nearby. The unique problem of, or not unique problem, but the main problem of zero energy building is that not always meet the requirement of sustainable materials, because sometimes we need to use materials that are not natural to achieve a more best performance for our building. The potential energy savings through an optimized design process minimize the heating and cooling loads is usually more influential than the use of innovative HVAC solution. Then it's very important in our zero energy building design to use and take advantage of the passive strategies. What I have told before, it's important to think about the building envelope design for a zero energy building, because having a good envelope is an important factor that affects the building performance. That means using thermal insulation, air barriers, air cavity, and exterior finishing. That means that our envelope is no longer just a layer of bricks, but it's composed of several layers that has to be studied, analyzed, and controlled. Also, our windows and roofs. The roof is no longer just a concrete slab, it's also layers with different materials. Windows are not more single glass window. We need double or triple glass windows. Here I can show you some kinds of layers for envelopes, for walls. Here we can see how it's going to be thick and our wall, how much materials we need to use, and how different they are. And it's important to know that the different combination of the envelope layers and the choice of materials depends on site climate, performance of materials and the result required. That means that if I am in Europe, I can have an envelope with materials and order of materials that are different from an envelope of a wall created in Saudi Arabia, because Saudi Arabia has different climate, a different need. That means a different performance of my wall. That's why we need to study better our materials. What we need to study about our materials, we need to study the density, the thermal resistance, and the reaction to the moisture. Analyzing these three features, we are going to have a U value. I don't know if the U value is known or not, but the U value, we can call it as a heat transfer coefficient. What does it mean, a heat transfer coefficient? It's a coefficient that measures the amount of energy, heat, lost through a square meter of that material for every degree difference in temperature between the inside and the outside. That means that our U value measures the rate of heat transfer in my material. If I have different materials in my wall, then I will have a U value of my total layers or total wall envelope. This is, it could be calculated, of course, with softwares, but this is the formula to calculate it manually. And then the third feature of our zero energy building is the renewable energy present inside. The renewable energy is energy which is generated from natural sources like sun, wind, rain, tides, and can be generated again and again as much and when it's required. Use of renewable energy can increase energy security because it's always present, and reduce dependence on important fuels, of course, while reducing or eliminating greenhouse gas emission associated with energy use. Because of course we know that also the use of fuels for production of electricity produce emission of polluted gases, which is not required only for a house building. We have two kinds of renewable energy that is used, of course, in our zero energy building. Solar energy, that it could be generated. It could generate electricity by the PV panels that are photovoltaic panels, or we can use it for heating hot water using the solar panels. And it could be utilizing also passive heating in the passive design. Then sun could be used in three kinds of energies production. Wind is a bit like, it's not really very good renewable energy. It's not really easy to achieve energy by a wind, but sure, it's a good source. In some areas that wind are abundant and high, where we can use this kind of small mills can also be used to generate electricity for running small equipment. Then it can't produce a lot of energy to cover more than some equipments in our houses. When we are then going to design a zero energy building, we have some steps to keep in mind. We have to start with a climate and site analysis, because it's important. Based on my climate and site analysis, we are going to design the architecture building using the passive strategies, and keeping in mind the kind of materials that we can use to achieve a good envelope. Then we start with a climate and site analysis. Then we have to design our passive architecture, our passive building. We choose materials for the envelope, taking in mind that it's present, of course, on the market or not in our market. The features of this kind of materials, calculate the envelope U value, making we almost use a lot of kind of envelopes, not in the same building. I'm thinking when we start to design a zero energy building, we start to have an experience with different envelopes and start to consider different U value, and then analyze how would be their performance. Of course, lower is our U value, better is our performance. Analyze the envelope performance in extreme climate conditions or during year using a simulating software. What does it mean? It means that if I am doing my design, my zero energy building design, if I'm doing it manually, then I will take in consideration the extreme climate conditions. Then my extreme in hot climate and extreme in cool or cold climate. Or if I am using a software, then I could use a simulating software to simulate all our year conditions. Then we have to design an HVAC based with high efficiency, estimate the energy needs. And once I have estimated my energy needs, taking in consideration heating, cooling, and equipment, I have to design the PV system based on the energy needs. الخبر NZEB residential building. What does it mean? الخبر nearly zero energy building. Why nearly? Because it's not the zero energy building is not achieved at all. It's almost achieved. That's why it's called nearly. Residential building, because I have chosen to do a study research about how would be realizing the zero energy building in a climate like الخبر, that it's a region, a climate that in average of the Gulf climate in general. Why I have chosen KSA? I have chosen KSA because the Vision 2030 is looking for a sustainable architecture and sustainable life in general. And I think Saudi Arabia is working on taking some steps toward this kind of architecture. In fact, according to the PB Statistical Review of World Energy 2017, Saudi Arabia was the world's 11th largest consumer of total primary energy, and it's a very high number to be only in Saudi Arabia, to be only about 33 million population. The total consumption of electricity in per year is 8,889 per capita. Per capita means per one person. That it's really high, because if we can see that compared with Europe, Saudi Arabia, it's 8,000, almost 9,000, while Europe it's about 5,500. When we are going to see how electricity is produced, we can see that the total energy sources of in Saudi Arabia is by fossil fuels. The renewable source is very low; it's about 0.1%. While in Europe, I am comparing Europe because I was studying my life. I'm European. I'm comparing Europe for that region. Then fossil fuels are about 48.9%, while the renewable energy is about 15.7%. It's not very high percentage for Europe, but it's going to be higher because for For the new standards, they are going to use zero energy building for all new buildings from December 2020. Here we can have some statistics about how much primary energy and consumption in Saudi Arabia is very high. Building residential government buildings in general, in case A, are almost consuming 80% of the electricity generated in the kingdom, while the AC represent more than 70% of this consumption. That's a very high number. If we are thinking about the residential sector, is about 51%. That's also is a very big number to be only a residential. We are not talking about industrial or production consumption. Then Saudi Arabia has started taking some measures like increasing electricity tariffs, and also taking some standards from 2014, 2017 that are using standards putting a U value for walls, roofs. This was the first U value standard, and the second one that it has a U value about 0.4 for walls and 0.24 for roofs. What are the strengths and weaknesses of having a zero energy building in Saudi Arabia? The strengths are the solar energy. In Saudi Arabia, there is a very good potential solar energy, and for the production by photovoltaic, of course, and also has a good wind energy production for the presence of wind in some parts of the territory, and also the diffusion of the single-family homes. That is not better, but it's easier to apply the principles of zero energy building. What are the weaknesses? The high direct normal irradiations means high surface temperature. What does it mean, high surface temperature? We have to consider that the photovoltaic panels and solar panels are used more in the European climate, where the sun is not really hot, and the irradiation, the normal irradiation, is not very high to have a high surface temperature. While here, the surface temperature could arrive also to 90 degrees or 100 degrees. That means that our panels are not going to work better. They are not going to have the best performance. For that problem, I think that the Middle East in general, because it's a problem of all the Middle East with the PV panels, has to work on researches and work to product some PV panels for their own territory and for their own climate. The presence of the sandstorms is another problem that could have our panels, our solar panels in general. And at the end, the high initial cost, of course, because zero energy building has a high initial cost. Even if in the life of the building, it could minimize the cost life, but at the beginning, you have to have a high investment in it. Reduce the efficiency of energy production devices. As I told you before, if we have these problems of sandstorms and normal irradiations, and the high cost of maintenance. Then here, I can describe my study research. I'm not going to describe all my study research. I'm going only to describe the part of the project, the zero energy project itself. I have used passive strategies, working very good on the envelope. In fact, I have used a PCM. The PCM is a phase-changing material. It's a new kind of material that are doing some researches on that could keep heating and release it during the cool periods. To increase insulation thickness with high performance, I had increased my insulation. I have used double glass windows to have a better performance of my windows. I have reused the traditional element of mashrabiyya. In fact, use the mashrabiyya. It's a wooden baluster. The feature of wood to shade and to decrease the humidity and the airflow controlling is very, very good. The use of solar protection devices. I had also installed a canopy on my roof to reduce the roof solar exposure. And I have scheduled the heating and cooling system. I have used the cooling and heating system only during about 6 months during the year. Then I have used the cooling system for 3 months and the heating system for 2 months or something. I don't remember how much months, but it was scheduled like my building could work as a passive building for almost half a year. As you can see here, my U value is 0.14 for roof, almost 0.15 for my roof, and double glass is 1.89. External wall it's 0.14 also the U value. We can take in consideration that the KSA new standards for the U value are working on a U value about 0.24. That means that my U value is really low. I have used Vuvi Plus simulation. Vuvi Plus simulation is a software that could simulate the climate, the inner environment, the external reactions of my building with the environment, and also the performance of my envelope. Here I have analyzed the power panels, the PV power panel, how potential is my photovoltaic panel. I can see that my site in Khobar here, my site in Khobar compared to Italy, has a very good potential. In fact, here we have about 1,800 kilowatt hour per meter square, while in Italy it's about 1,200 or 1,300 maximum. That means a very good potential for Al Khobar site and PV power production. I have used this kind of PV panels on the canopy that are integrated, and I have chosen to put it in a 0 degrees tilt to be flat, because to achieve more, to have more space for my panels, and using my PV panels like that in this position, even if the best position would be 20 degrees angle, but it will not be present enough space to use enough PV panels. Then using it like that, I could cover 94% of my building energy needs. In fact, with if I am going to analyze my building performance using only the passive strategies, I could reduce my energy need to about 52% than a normal building in Al Khobar. Then it was more than 50% of my needs without using any renewable energies, only with passive strategies. That it's, I think, in my opinion, it's a very good percentage. And also, I had using then the renewable energy, I could cover the 94% of the energy need, having only 6% of electricity from outside of my building. And this is the end. Thank you for listening to my okay. Thank you. You can now ask if you have any question.
Thank you, Fereal. I already notified everyone if they can send us their questions now.
Thank you.
Okay, so let's discuss a little bit. The project that you had study, is it constructed and already in Khobar, or still in study?
It's a study.
Ah, okay.
Yeah, it's my thesis research for my master's degree.
Oh,
it's only a study. It's not constructed. But I think it was a challenge because it's a bit different. We used to have studying zero energy building and passive buildings in European climate. That it's really different. It's like it's an opposite climate. If we compare it with Saudi Arabia, or if we compare it with Khobar and Eastern Province. That's why I was excited, because it was a challenge to see how much would be different and how much we have to consider some features, like the air barrier. In Europe, we have to use the air barrier in the outside layer, while in Saudi Arabia, we need to use it, or in Khobar, especially in Eastern Province, we need to use it in the inner side, because of the moisture and the humidity present in the climate, and because of the heating, because here the problem is heating, while not heating, sorry, the hot climate, we need cooling and the inner space, while in Europe we have the problem of cold climate, then we need a heating inner space. It's like an opposite situation.
We have a question from Ayad. Do you have any study regarding the difference of building construction costs between the normal building and the, let's say, the nearly zero energy building?
Okay. I don't have a study, but in my study, I had given some compare between a normal building and a zero energy building. In fact, if you can see, I have told in the research, I have told that with only passive strategies, I could decrease my energy need of my building about 52%. That it's very, very high percentage to decrease between two buildings. And what I think it's important to know that we can transform a normal building in a passive building, or even in a nearly zero energy building with some steps.
Okay, this is a question from Abdul Manam. What is the required UV value as per Saudi building code for commercial buildings?
The required U value is 0.24 now for the walls, and about let's see how much for the roof.
This is for commercial buildings?
Yeah, it's for all the government buildings, commercial and residential. For the roofs, it's about 0.24 walls. It's 0.4. Yeah. Then for the wall is 0.4, while for roofs is 0.24.
Okay. So these are all the questions that we have. No, we still have questions. This is from Dr. Hand.
Okay.
What makes this study special to KSA? I can use the same procedures in Egypt or other place.
I'm sorry, is a connection is low?
Let me go again. What makes this study special to Kingdom of Saudi Arabia? Can I use the same procedures in Egypt or other places?
Yeah, of course. The same procedure is the same everywhere. But what is different between some place and another, it's how you are going to use the materials and how would be the performance of this material in this place. Like some materials, you can't use it in Europe because it's very like PCM. You don't need to use PCM in cold spaces, because PCM, the important of this material is transforming the heating in the hot periods in heating in the cool period. I don't know if it's clear, but the PCM feature is when you are in hot periods, then during summer, the PCM can achieve all the heat energy that can release during the cooling period.
Okay.
And you don't need it in Europe. You need it in places like Middle East, case A, Egypt, or even other places with hot temperatures.
Okay, this question from Dr. Salah. Can you clarify what the zero energy solutions that you include in your study?
The zero energy solution is what I have included are the passive strategies. That is the first important step. The second step is using a HVAC system with high efficiency, with scheduling periods, and using of course renewable energy with using panels, solar panels, PV panels, and solar panels that could produce 94% of my energy need.
Okay. There's a question, but I'm trying to read it, so I can't tell you the question. Okay, this question from Ihab. How can we make this in our existing small apartments for being zero energy, or at least reduce usage of energy, and also how to make it sustainable and renewable?
Okay, yeah, you can of course do it, but it's a work on all the building. You can't work only on your own apartment. You need to work on all the building with a retrofit procedure. That means that you are going to add a cover, like a coat, an insulating coat on your building to develop your envelope performance, to change your windows with double glassed or triple glassed window, and of course changing your HVAC system.
Okay. About the amount of technicalities and the procedures that you had in certain building, what is the culture aspect and the importance of this culture aspect for the end user, or let's say the culture aspect, the understanding aspect for the end user who will use the building and most probably will do a lot of changes in the building without even referring to the original design or the designer?
Okay, then you are asking why a customer will choose to use a zero energy building.
Mm-hmm.
That is your question.
Yes.
Isn't
yes.
it? Okay. Nowadays in case A, I think the customer is not really is not considering this kind of choice, because it has the energy that it's accessible. But if we are thinking about future, about sustainable choices, it's of course a more sustainable choice for our future, for future of the future generations. That's one aspect. Second aspect is the cost life. The life cost is going to increase, and what I have told also in my speech, that Saudi Arabia is working on increasing electricity tariffs to increase the awareness of people about the energy, how to use energy. Unfortunately, they are not doing campaigns to inform people how to decrease their consumption. But I think they are going to do it because they need, because people is now looking is having problems with the tariffs of electricity.
Yeah, the question is about the awareness of the end user and their understanding of the importance of these aspects and reducing energy, etc. There should be a more awareness.
The connection is very...
Really? Okay. So I will turn off my
is...
camera because it's maybe it's consuming the bandwidth. Is it better now?
Okay. Yeah.
Okay. So we were saying that the importance of for the individuals, the end users, to understand the aspects of all the energy buildings, etc. It's related also to others who can raise the awareness so they can understand the importance of it.
I think it's a governmental rule now to increase this awareness of people, because sustainability in Arabic states is not really known. But I think they are going to look for it because it's needed now. It's needed to be in the vision of the world.
Mm-hmm. Okay, we have a question from Dr. Hind. Could you please tell us the name of the used program in simulation and how it helped you in the study?
Okay, the software is called Wofi Plus software. I can write it.
Actually. Yeah, please.
Okay. Yeah. Wofi Plus.
It have English
software.
Version? Or is
yeah. No, it's in English. It's a German software, but it has also English.
Wofi Plus
version.
software. Okay.
Yeah.
How it helped you in the study?
It helped me to study the envelope, my envelope performance, how materials is working during the year. It could be analyze my envelope and my building in the climate situation of all during all the year, and it also gave me a HVAC system with a high efficiency, and at the end it could give me how much energy I need or how much energy my building require during a year.
Okay, so back to the apartment sustainable concept. This again from Ihab. So he replies to your reply. That's mean if I try to make it in an apartment, it will not be working. Could I have to change?
It could.
Sorry.
Not working. It could work to decrease your electricity and your consumption, of course, but it will not be a zero energy building. It will not be a zero energy apartment. You can decrease with some strategies. You can decrease your consumption, of course.
Okay, so we have another question about if we are saving about 95% of the energy, how much against it that we will have maintenance costs and utilities costs, or let's say facility management costs. Yeah, if we are saving, because it's everyone says that it's really high as a term.
Of course, zero energy building, the initial cost is very high. The problem now in KSA and Arabic states, or in hot states, hot countries, the problem is the maintenance, because as I told before, this kind of appliances for production of energy is made for cold regions, and there they haven't a lot of problems with hot and with sun, while here we are meeting a lot of problems with the irradiation that needs a lot of maintenance. And that's why I'm looking forward that in future the hot regions are going to produce panels because they need it. They are going to produce a lot of energy, of course, with this kind of panels, and they need to produce it to have their own features.
Another question: what about the UV rate? Let's say the ultraviolet actually rates that we have in Saudi Arabia, as especially in Saudi Arabia and mainly in the central region, we have very high UV rate. Which is a plus UV rate, which is actually the ultraviolet, I mean, which is a plus with the heating, is causing a lot of damage for the solar panels, the equipment.
What is causing a lot of damage for solar panels are the irradiation, not the UV. Yeah, the UV in Europe is higher than the UV in case A, as I have found in some researches, but it's not taking consideration in this kind of analysis.
Okay. So, there's another question from Dr. Salah. As I understand that you used the passive solutions to have a zero energy building. Did you consider the green building solutions before using any of the other mechanical or electrical solutions?
Yeah, this is another kind of building. It's a sustainable building because it's not producing CO2, embodied CO2, a lot of CO2, and it's not using fuels. But in other terms, yeah, I know that like the materials that I used in my building to achieve a good performance envelope, they are not sustainable materials. Yeah, I know it. But in this situation, if I want to achieve a zero energy building, and then I need to achieve a building that could cover its own energy consumption, I need to use a good material. And nowadays, I can have it by natural elements. I don't know if it's clear.
Hopefully, yes. We didn't have any reply yet from anyone. And so far, these are all the questions. And we will wait a few seconds. If anyone have more questions,
of course.
Then we can wrap up.
Yeah, of course.
So if anyone have question, please send it now, or we can just. Okay, I think we are done. Thank you again, Dr. Fereal, for your time and for the informative presentation. And thank you everyone who attended with us tonight. Thank you.
Thank you. Bye.
Grazie.
Grazie lei. Ciao.
Ciao.